My name is Chien. I'm a alumnus of Columbia University, getting my PhD degree in physiology in 1957. And I've been at UCSD since 1988, and in the Department of Bioengineering and the Department of Medicine. And it's a pleasure to participate in this program, celebrating the Asian Pacific American Heritage Month. I was in Columbia from 1954 to 1988. So that makes it 34 years from graduate students to faculty. So Columbia has a very important influence on me and a very strong feeling for my alma mater. So I'm very happy to join this program today.
Thank you so much for being with us today. We're really excited to have you. So my name is Naveed Tavakol, and I'm a PhD candidate in biomedical engineering under the advisement of Dr. Gordana Bunyak-Novakovic in the Lab of Stem Cells and Tissue Engineering. And so today we're going to be talking about your experiences both at Columbia and also in your career, and how bioengineering has really shaped your career and how you shaped the bioengineering field itself. So first, I guess, where are you from? Where did you grow up?
I was born in Beijing, China, and I was there till I was 5 years old. When the war with Japan broke out, then I went down to Shanghai to our family. So lived with my grandfather in Shanghai. I grew up in Shanghai from the age of 5 to 15, about a decade. That's the formative years. And then my father, the war was over. My father returned to Beijing and the whole family went there. So I went to Beijing to transfer to high school junior year. Then I went to the Peking University to study pre-med. Then due to the Civil War, my family moved again to Taipei, and I transferred to National Taiwan University and got my MD degree there. After a year of ROTC training, which was mandatory, and then I came to Columbia in 1954, beginning my PhD study, as I mentioned, in physiology.
Wow, that's really interesting. So how did you first get into the STEM fields and then eventually go into medicine and then want to come to do your PhD?
Well, I was always interested in math, actually, even when I was a very young, maybe elementary school student. I was very interested in the numbers, how they are related to each other, that I could play with them. So I enjoyed math particularly. And I think math is a critical element of STEM. Even though it's the last one of the four letters, I think that's the basis for everything to be quantitative, and particularly for engineering and now for science. When I studied in medical school, biology was very qualitative, very little quantitative approach. But now biology is also quantitative. And of course, chemistry and physics always have been like that. So science, technology certainly depends on all of these. So STEM actually is one thing together. I mean, engineering without math, you just couldn't do it. I mean, students sometimes cannot go to engineering because of their lack of math expertise. So I think the four letters are all important, but maybe I'm prejudiced. I particularly would like to emphasize math.
Definitely, and I agree. I think it's interesting because over the past 50 to 70 years, I think biomedical engineering, bioengineering, and biomedical engineering have kind of come about just by application of math and all of this to physiology. Um,
Yes.
but I guess how do you think your experience has really with the field kind of being developed in your career, and you also kind of influencing the field to form itself? How have you seen biomedical engineering as a field kind of shift over the past years?
Where biomedical engineering certainly has grown tremendously and evolved from a very young discipline with a very small number of people working on it. When I was in graduate school at Columbia, there was not much bioengineering in the country. And I was in the Department of Physiology. And because the physiology department at that time was not quantitative, with very little application of math to the physiological science, so I took many engineering courses at Columbia University and also at a nearby City College of New York. Courses such as control theory, biomechanics, circuit analysis, so all kinds of engineering courses. My colleagues, my fellow students laughed at me. Why do you take these courses that are not relevant to physiology? But I think that's what I love. People cannot get away from what they love. I love math. I want to apply math to a discipline, and engineering is perfect. So, and it's related to physiology. At least I thought already that time, but other people in the department did not think so. I was very lucky to be able to take these courses that really shaped my career with that foundation. I don't have an engineering degree. People always think of me as an engineer, but I'm not a qualified engineer in that sense, even though I belong to institutes like National Academy of Engineering and so forth, but I do not have an engineering degree. So people don't need a degree to do what they want to do. So, but the field, you asked me about the field has really grown tremendously. As I mentioned, there was not very much at that time. At that time, very few people were trained both in engineering and in the sciences such as physiology or biological sciences. Very few people were cross-trained. So we had to collaborate. So I was very fortunate that I was able to collaborate with a professor of civil engineering and engineering mechanics, Richard Skalak. And I published 3 papers in the one issue of Science on rheology, red cell deformability, and aggregation. He read it. We never had met. He read it. He said, "This is very interesting. I would like to collaborate with you." I was so happy because I wanted to have engineering colleagues. Did not have enough engineering, and so we became partners since that time. So it is really very fortunate I was able to team up with an outstanding engineer. And we worked together for 30 years. We went together from Columbia to UCSD. We kept our teamwork. Unfortunately, he passed away more than 20 years ago. No, not 14 years ago. So I lost him as a treasured partner, but I benefited so much. Another colleague I benefit from is Sheldon Weinbaum. Shelley has been in the City College of New York, so we also collaborated. I was in New York. So these two engineers had big influences on me. And then after I came to UCSD, I came to bioengineering department. YC Fong recruited me, and Ben Swaifaki, they called me up. They wanted me to come. I said, I'm not an engineer. I don't have engineering formal training. They said, what you're doing is biomedical engineering, and we need you. So I came, and I was lucky to work with YC Fong and other outstanding bioengineers here at UCSC. So I think what I wanted to say actually is that we needed partnership, collaboration very, very much to bring the disciplines together. Today, people are trained in both, like the biomedical engineering students like yourself at Columbia and our students at UCSC and elsewhere. You're trained in both. So you have biomedical training and engineering training, biomedical engineering. But in those days, we're not lucky enough to get that, but we collaborated, which was very, very precious. But even today, I think, even though each person has a training on both sides, but one person really cannot cover everything.
Yeah.
So I would like to emphasize that collaboration is extremely important. People can be complementary and help each other and synergize their ideas and expertise to achieve things that none of us can achieve alone. So I would like to stress teamwork, collaboration, particularly in biomedical engineering as a interdisciplinary field.
I totally agree. I mean, I think a lot of the field has been based upon all of this collaboration that you yourself took a part in. But could you elaborate a little bit more on your time at Columbia and what you really enjoyed, or some specific memories that you have from being here for so long?
Well, at Columbia, it was really a fantastic experience. I mean, I owe everything I have due to my training at Columbia and my career built up. By the time I came to UCSC, I was already a full professor for many years, fully developed. So my development from a young graduate student to a fully tenured senior faculty, it was all of this took place in Columbia, and I was benefited by all the wonderful people they already mentioned, Dick Skalak but many others in physiology, in medicine. I was able to collaborate with people in clinical medicine a lot in Columbia because we're lucky that physiology and medical school are just adjacent, actually almost same building. So I was able to collaborate with a lot of medical colleagues to make the engineering really medical, not just bioengineering, but biomedical. So I really treasure that very, very much. People in almost all the major departments, medicine, surgery, orthopedics, all of the OBGYN, and all of these. It's unbelievably rich environment there. And from the engineering side, I'll collaborate with many of the engineering colleagues. That's actually, as you know, 50 blocks away, but the subway was pretty fast. And so I went down there, and Dick came up a lot. And actually, we lived very close in New Jersey. So we saw each other even more at home than at school. So we didn't have to take the subway, just a 5-minute drive, we could see each other. So this is really a marvelous period of my life at Columbia. I always remember that. And also even after I came to UCSD, Columbia physiology did not have anybody at that time to teach cardiovascular physiology. I came back for several years to teach the course. So I was still a part of the department. That, of course, stopped after they got the right person to teach the course. But I was also very fortunate in the late 1990s when Columbia wanted to start biomedical engineering department, I was asked to be the chair of the advisory committee to get it started, because there was some internal problems between the various units, and I was able to get together, work with Van Mao, the founding chair. He's wonderful, and also Dings Zvi Galir. So the three of us were really working together very, very closely and very hard to get this department started, to form it in 1990 formally, January 1990. So it's now more than 20 years, actually. There will be a celebration, I think, is going on, that EDCO is organizing that. I think this is fantastic. It's fantastic. So I treasure all of these relationships I have had with Columbia.
Yeah, and we're definitely all thankful for all the work that you put in to help push the department. As a grad student, I'm really thankful for all the opportunities we have now here at Columbia. I want to shift a little bit to your family and some of your strongest influences in your life that kind of have kept you going in all of the like non-academic work, I guess.
Yeah. Well, speaking of family, of course, my parents had big influences on me. My father was a chemist. When I was born, 2 weeks later, he came to UIUC, University of Illinois, Urbana-Champaign, to study for his chemistry PhD. And because my mother could not come, he really studied hard. My father, in less than 3 years, he finished his PhD, and he returned to China to become full professor at the age of 27, right after the PhD. In those days, I mean, there's so few PhDs there, and he became a full professor, and he had a tremendous influence on me, because I saw him how to behave not only as a scientist but as a person, how to be fair, righteous, to do the correct things and never try to take advantage of anybody, but try to help people. I mean, that's what he did. He later became the president of National Taiwan University and president of Academia Sinica. It's like all the national academies rolled into one in Taiwan. So he was in these positions, but he was never a person who prides himself and looked other people down. He always tried to help others, be really very kind and supportive and generous. And I learned from him. I often said, if you follow the examples from the top, at least you get to the middle. You may not get the same level. So I'm very grateful for whatever he did. He never said too much to me about how to behave, but I just watched him. I learned how to do that. He was such a wonderful role model that he had big influence on my life. Now, of course, my own family, I was very fortunate to meet my wife, Casey. She was a medical student in Taiwan University 2 years after me. So we met in the university in the later years of my study. So we began dating, and then I came to the United States, to Columbia. She graduated 2 years later. She came to United States to become a medical intern at a hospital near Columbia. I found her a hospital very close by, so within walking distance. I'm not sure that the hospital is still there or not. It's a Catholic hospital, and it's really less than 10-minute walk from Columbia. So We then married. We married in 1957, just before I got my degree at the commencement, same year. Then we had, yeah. So this was actually the most important event in my life. I mean, there is an interesting anecdote. We married in Medicine Avenue Presbyterian Church, Medicine Avenue, and some 20 years later, I found out Richard Scalak and his wife Ann also married in the same church. Now, there are so many churches, so many places in the whole world to be married in the same church. It's really so interesting. But anyway, that's a side event. But that marriage that was 4 years ago. We just had our 64th anniversary. It's wonderful. It's like, it's the most important thing in my life. I mean, she is so supportive, Casey. She's a pediatrician, but she always puts her work second and try to help me first. I mean, sometimes I really feel that's too much. I almost couldn't take it, and I try to help her as well, but not as much. So she is extremely important in my life. We're still together, fortunately, very happy, and we have 2 daughters, and they're all around 60 now, and both were older daughter is in business. So she worked for Morgan Stanley as a vice president, but now she has her own website advising people how to work successfully. My younger daughter is a ophthalmologist, eye doctor. She just retired. She has 3. Each of them has 3 daughters of their own. So I have 6 granddaughters. For 2 generations, I've only girls. It's wonderful. However, I love every one of them. And now we used to see each other at the holidays, but last one we didn't get together because of pandemic. However, over the last year or so, we have regular Zoom meeting every week. So actually we see each other a lot more. But I want to say family is extremely important. I owe a lot of my progress to the support of my wife particularly, and my daughters, and even my granddaughters that give us so much joy and happiness. And then I mentioned about the importance of my parents. My parents are complementary in personality. My father was very introvert. He did not say much, but very kind, but never said. My mother was very outgoing. At any parties, she was the center of the party. Everybody liked to talk to her and so forth. So they were very complimentary. I think I got a little bit of from each. I'm not that reticent as my father, but not as dynamic as my mother, but somewhere in between. So I owe a lot to them.
Thank you. Yeah, I think it's just so inspiring, and to hear about your journey back in China, then back in the US. It's really exciting to see that you still have like family as such a strong part of your life and your academic career. So what has been your experience as an Asian American professional in STEM?
Right. Well, before I go to that, speaking of family, I think besides my family in terms of home, marriage, and so forth, I think I have a wonderful academic family, both at Columbia and the UCSC. The people we work together have been like a family, and part of it is helped by my wife, Casey. We regularly would have parties in our home, inviting people in the lab particularly, and we met. We have a wonderful time always. So my trainees, either graduate students or fellows, we're friends more than I'm not a mentor, then not just a mentee. We're friends, and we're friends for life. And many of them are department chairs now. They we still communicate and get together. Now we don't get together during the last year or so, but in 2019, when I retired, although I'm still recalled for partial duty, but I did retire in 2019. In end of October, we had a party. They have a party for me, and my trainees. They came from all over the country to that event. It was so heartwarming. I was so grateful and appreciative. I just want to mention that I have extended family beyond my true immediate family. Now let's go to the next question you have. It is the question about the Asian American. I think it's wonderful that we have the Asian Pacific American Heritage Month because we really need to get the contributions by the Asian Pacific Islanders to this country in the past and now, and there'll be even more in the future. I think we should recognize that and encourage that. And this this event is really wonderful that we're doing that for the to pay tributes to the generations of Asian and Pacific Islanders who have enriched Americans' history, and they are critical for its future success. I think this is wonderful. So for all of us being an Asian Pacific American, we should participate actively and contribute to not only this month, but for all the time beyond, for the collective effort to make this country, the United States of America, a truly the country for everybody, including the Asian Pacific Islanders, to be treated as equal to everyone. We don't want to be treated specially to be more, but we want to be equal as a person. Now, I would say that when I mentioned Dr. Y.C. Fong, when he came to San Diego, that was back in 1960 or so, he had trouble buying a house at that time. Not trouble, but some houses, obviously they sold it later to not only non-Asian, but Afro-American and other ethnic groups. They sold it to these other, sort of like WASP. And so he had a discrimination even at 1960. By the time I came in 1980s, late 80s, I did not experience that already. So the country has moved forward. Even in San Diego, we could see the change. But in parts of our country, still this is not the case. And I think we have to endeavor to make it throughout the country to have all the ethnic groups to be treated as equal. That's the founding spirit of our country. We've got to treat everybody as equal. So we recognize every ethnic group for their special contributions and characteristics, but in terms of all kinds of privileges and activities, everybody should be treated exactly equal.
Yeah, agreed. Thank you so much. I think it's something that we as a country need to work on because, like you said, there are some areas where this is more the case, more representative in the community, but I don't think this is widespread in the nation. But kind of touching on that, I think your career kind of exemplifies a number of accomplishments that someone in your position would be able to make over your long career, and how you've kind of shaped the field of bioengineering in this way. But could you point out a few specific accomplishments that you are most proud of, or things that you feel that have been your most valuable contributions, or most meaningful to you for the field?
Well, first, I would say the contributions I'm most proud of are the trainees I've had, the students and fellows. They have become leaders in the field and contributed to biomedical engineering. So they amplify whatever I could have done. It's one person can do only that much, but through them, the impact on the field is so great. I am always happy to hear what they have accomplished, and I'm most proud of them for what they have done. Now, for my own achievements, I think I'm very happy that I'm one of the earlier, I was not the earliest, but one of the earlier group of people, particularly my collaboration with Dick Skalak and Shelley Weinbaum. And what we have done, many of the studies are still being quoted today, and so they have significant impact on the field. And I'm glad to see the field has moved forward so rapidly during the last, since I studied, last 50 years or so. And this is really terrific. And as far as my own achievement, many of them, I would say our achievements, because I was not the only person usually. And I think it's that we're the first one to establish the fundamental mechanisms for blood rheology, from flow mechanics all the way down to molecular biology, how the red cell membrane proteins govern the deformability and red cell aggregation influencing blood rheology. That's one of the, I think, our major contributions. The other major area is mechanotransduction, particularly endothelial cells. And this is the work I've done mainly since I came to UCSD, but it started also in Columbia in a initial way. So this field is, when we worked on that, there were about less than 10 groups. I mean, I can count them on the fingers of my two hands, and I knew who was working on that. But today, mechanotransduction, if you search for publication, there are so many, and people are doing that. We were doing that in the cardiovascular field. That was almost the main part of the system that was focused on. But today, every system you look at, all the physiological systems, you see mechanotransduction, which is nerve, muscle, all of these. So it's very exciting to see the fields grow. As somebody who started this field early, and you see that it's just tremendous. It's very exciting. So, and of course, I feel very strongly about the importance of the organizations for the field, such as Biomedical Engineering Society, American Institute of Medical Biological Engineering, AMB, and from the physiology side, American Physiological Society, APS, and umbrella organization, the FACET, Federation of American Societies for Experimental Biology. Now, I was very fortunate that I served as president of all these societies and federations. I think this is one of the most exciting experience I've had, to work for a group. Now, to be a president, you're not the top person, you're the servant. I try to get everybody together to have a common goal to advance the field, not just our own work, but the field. We advance in American Physiological Society, we advance physiology, and the FASEP, we advance all the experimental biologies together. In BMES, we advance biomedical engineering, and AAPIHM is even broader. So I've had these participating in these grassroots organizations and also the overriding federation type of organizations. The ultimate aim is the same, to get everybody together and to lobby for the field. Again, when the funding of from the government is not enough, we lobby the government to raise the funding. And when I was a president in these fields, I was able to contribute to that. So I regard that as a major accomplishment also. And when I was president of AAPIHM, I helped the NIH to establish the National Institute of Medical Imaging and Bioengineering, NIBIB, Biomedical Imaging and Bioengineering, NIBIB. So I was very fortunate to be there and to be able to contribute. I mean, of course, many people did that together. It's a teamwork, just like in our research. But in these organizations, even clearer that we need teamwork. These kind of federation, we have different units. They may not have the same idea, but we find a common ground. We push for that and to get that done successfully. That's most exciting. So you ask me what am I proud of? I mean, these things I'm very proud of. Besides my own research, work with my colleagues.
Yeah, and you still see the effect today. I'm fortunate to be able to go to these meetings and meet people, and for trainees getting the experience to develop our skills in biomedical engineering, but also see how this can be applied in the future. Kind of going off of that, what do you see as your last like advice to any future bioengineers or future people interested in getting into the field?
Well, I think first we have to have excellent preparation. I mean, STEM would be a good starting point. And after that, we have to apply our knowledge to a given field to pursue excellence, whatever we do. I mean, decision is very important to choose the field. Once you choose the area you work on, the key is to pursue excellence, to do the best one can. Everybody has different capabilities, talent. We have to utilize our talent to the full extent. So we came to the earth, and when we are gone, we left behind something we have done the best. It doesn't matter what we do. I mean, some can be very small type of work, others are big, but it doesn't matter the scale or the importance. We do the best. We try to do the best we can. Everybody has different capabilities, but we must reach our capability. Then we're happy. Don't try to overreach. I mean, like I cannot try to be a NBA basketball player. That would be a wrong thing to do. Obviously, that's the extreme. I mean, just use that as an example. We have to choose the right field, and once you choose it, to do the best we can. I want to repeat that, to do the best we can to achieve excellence, and then to work with people, collaboration, teamwork, that's very critical so that we can work together. I have a principle of working with people. If you and I work together, there's 100% of the work, I will try to do 60, I mean, if you allow me, and I'll only take 40% of the credit. The 60-40 principle has worked very well for me. People always like to work with me. They see, he is not trying to take advantage of other people. You know, that helped me. It seems like I'm losing, but I'm gaining. By losing these little ones, I'm happy to help other people, I gained in a big way to have more collaborators, and they trust me more. So this is very important, I think. So I've mentioned that you have to have the decision to choose the right people, discipline, and you have to pursue excellence to do the best you can, and then to collaborate, to work with people, to have give and take, to be willing to go for the team. And also for the team, there is the big self, that's the team. Just like the associations, the federations I mentioned, these are the big selves, or Columbia or UCSD, these are the big self. Then we have our own small self. We're a part of the big self. We're depending on each other. The big self needs the strong small selves put together, collaboration together to make the big self really grow and succeed. But then a small self, we need the big self, need that to help us. So this is a mutual relationship. So we need to consider that. So in the field, again, I want to stress teamwork. And in teamwork, sometimes we can be team leaders. Then we have to learn how to do that. But most of the time we're team members and we have to work for the team. And remember, our small self must work for the big self, for the good of our big self, the team, the university, the association, and all of that. So these are my thoughts about the question you just raised.
Yeah, I think it's very inspiring to, keep in mind everything is really there for the team, and how it benefits everyone. So thank you so much for joining us today for Asian American and Pacific Islander Heritage Month. I really appreciated talking to you and thank you for taking the time out of your day to join us for this interview.
Well, it's my pleasure and privilege. Thank you for having me.